Hi, this is a presentation on how to use SQLAlchemy with a basic simple web application using Flask. This presentation is mainly for beginners who have not used SQLAlchemy or an ORM before. The database that would be used is SQLite, which is a file-based database. It is available as a built-in module in Python. And it is a SQL database, but it is file based. It's not a typical Oracle or MySQL Postgres type server database. This is how I'll go about the presentation, with a very brief introduction on what an ORM is and initially talking about SQLAlchemy basics. I'll go over a little bit about how SQLite is actually used if you're using DB API and not using an ORM. I'll give an example of a small web application and a basic view function that is relevant to this presentation. Then I'll give information about how to install and what to configure if you want to use SQLAlchemy, if you want to use a SQLAlchemy extension with Flask, and if you're working on a web application that uses SQLite. And then we will dig a little deeper into how to use SQLAlchemy to define models, creating tables, defining relationships between tables, how the querying works, all the CRUD operations, creation, read, update, and delete. And then a little bit about how to catch SQLAlchemy exceptions, and also how to inspect the SQL queries being generated. So an ORM is basically an object relational mapper. It's kind of a layer of it's a layer of abstraction which hides the relational view of data and allows a web developer to access and manipulate data as class objects. So it basically hides the details or the intricacies of the data store, the querying mechanism, the SQL, and all you need to do is define your data as class objects and even manipulate and use them, define methods on the classes, and you can retrieve all the information from your database, or you can do all the CRUD operations, and the ORM will take care of most of the stuff. So it kind of becomes handy to use a database abstraction layer, because then it's easy if you're changing the database, the vendor, the SQL. Also, there are lots of database related operations that we need to do if we are not using a DAL or an ORM, and using an ORM helps take care of most of that stuff. And basically it supports the MVC model of data, and then allows for faster application development. So SQLAlchemy basically is an abstraction layer. It's a framework, and it can be used as SQLAlchemy core or a SQLAlchemy ORM. The core basically consists of an engine on top of the DB API, so it manages connection, pooling, different, and provides a dialect layer which is used to basically identify the type of database that you're using. So if you're using Postgres versus you're using Oracle or MySQL, the dialect part takes care of that. And then it has its own SQL expression language. That's basically an abstraction on top of SQL that you can use to manipulate the data. So you can use SQLAlchemy core, or you can use a SQLAlchemy ORM, which is another thin layer on top of the core that can be used to, that makes it much easier if you are just interested in focusing on the web application part of your code. This presentation is going to use SQLAlchemy as an ORM, basically using the Flask extension of SQLAlchemy, which allows you to access all the modules of SQLAlchemy and SQLAlchemy ORM classes. So SQLite is basically a file-based SQL data store. It is included in the standard Python library. If you are using SQLite with this DB API and you have a Python application, you can access it in this way. So you can first you need to open a connection with the database engine. That's kind of like you want to open a file, or connect to, or use a file descriptor or something like that. And so you import SQLite, you create an instance of the connection object, which is SQLite.connect. Example.db in this case is the name of the file that you are actually using as the SQLite database. And then you need to get a cursor object, which then allows you to run your SQL commands. So c.execute is basically the main method that you're going to use to run or execute all your SQL commands, whether it's create table, or if it's a select statement, or any other excuse me, SQL query, any insert statement, things like that. And then once you have executed a series of SQL statements or create table, DDL, DML statements, you need to commit the transaction before you can see any changes in the database. And then if you want to query the results, or if you want to query the database, the methods that are commonly used are fetch one, fetch all, and fetch many. In the end, once you're done with using the SQLite database, you can close the connection with the database using connection.close. So in this case now, we are not going to use the DB API for SQLite, we are going to use the SQLAlchemy ORM. And so for basic installation, all you need to do is create a virtual environment, create a directory in which you want to work, and then you just do pip install flask SQLAlchemy or apt-get install flask SQLAlchemy. This is I'm running on a Linux system, so I'm using pip install. And if you want to check the packages that are getting installed, you can do pip freeze. You can see that by just installing flask SQLAlchemy, you are actually installing all of the following packages, that is Flask SQLAlchemy, Jinja2 Workzoid comes with Flask. You can also see the SQLAlchemy package being installed, and you can see the versions of each one of those. So now in your config file, or in your models file, this is the basic configuration that you need to set up if you want to use SQLite with SQLAlchemy. So these two series of commands, or the code state, the part of code is basically to configure SQLAlchemy, or to tell SQLAlchemy that the database that we are using is SQLite, and this is the path. This basically creates an engine, and create an engine is a class provided by SQLAlchemy that takes care of connecting, of the connection pools, of which dialect to use, which database to connect to, the information about the database that it needs to connect to, and everything else that comes with it at the lowermost level, at the DB API level. So now we'll move to some examples that tell us a little bit more about how we can define models, create relationships between tables, and do the basic CRUD operations, and make queries into the database and see the results. So this presentation follows an example web app which allows users to enter their username, email, living address, and upload titles of podcasts recorded by them. For the sake of simplicity, the set of podcasts uploaded by each user is unique. The schema design includes two tables, a user table and a podcast table, with a one-to-many relationship between them. A user can have many podcasts. However, again, for the sake of simplicity, we assume that each podcast is unique. So this is an example of a simple view function. By the way, if you want to look at the code for the models, the views functions, and the files, you can go to the first page of this presentation and have a look at the code. So defining the model. So basically what you need to do is, after you do the configuration for SQLAlchemy that you want to use SQLite, what you need to do is create an instance of the class this is the SQLAlchemy class that controls the integration with Flask applications and provides access to SQLAlchemy functions from the SQLAlchemy module and the SQLAlchemy.orm module. So there is basically a declarative system in SQLAlchemy. So when you define, so what we really want to achieve is that we want to be able to define classes. We want to define our data as class objects, and we want the ORM to take care of the rest. We want the ORM to create tables, and then when we invoke methods like get, set, or when we want to make queries in the database, we want the ORM to be able to translate them into the relevant operations in SQL and give us back the results. So there is a declarative class. There is a declarative class called declarative base, that is used in SQLAlchemy. It is a meta class from which all the data classes that we define are derived. So if you were not using the Flask extension and you were using SQLAlchemy as it is, which you can also do, you would be defining the class and deriving the user class, for example. Here you would be deriving that from the declarative base class. However, in this case we are using db.model class, so the model class from SQLAlchemy is basically the same thing here. So here, because you're using Flask SQLAlchemy extension, it kind of makes it a little bit easier, so you have to do even lesser. So here we define our user class. So you want to define two tables, user and podcast. So for the first table, we want to define our object-oriented model, and it inherits from db.model, and this db.model is pretty much the same thing as the declarative class, base class of SQLAlchemy. And then we define the tables. So in the tables we want to define the columns, and to define that what we say. So if our table wants to have a username, if we want to have username, email, and address in the table, we define them here in our class, and then we create an init function to initialize them to whatever value we want to. And then what basically happens is that when this class has been declared, and once the class has been declared, because this is part of a meta class, because this is derived from the meta class, the declarative base class, it's what is going to happen is SQLAlchemy is going to create a mapper between this to an actual table that is created. So an actual table object is created after this class is declared by SQLAlchemy ORM, and it is also mapped from this class to that. There is also a mapping that is created using the SQLAlchemy ORM's mapper from this class to the table. So that way we can define all our database models like this as classes, and SQLAlchemy ORM is going to translate or make a mapping from the class to the table. So similarly for the podcast class, and one thing to note is that we have to define the primary key, and since user ID is a foreign key in the podcast table, we define that as the foreign key here, and that is how you define a foreign key. Another thing to note is that if two tables have a relationship, then we can define the relationship between classes as db.relationship. And so podcasts is the table with which we have the relationship, and when we mention the argument as backref, it means that even the podcast table can now access the user class with some back pointer or something like that, some back reference. So all we do is we define classes, and we define relationships between those two classes, and SQLAlchemy converts them into tables, creates a mapping between the class and the tables, and takes care of any relationship that exists between those two, and also makes a note of something is a primary key or a secondary or a foreign key or something like that. So while it does that, we do need to invoke the create all method to actually go on and create the tables. So before that, it only makes a note of the things that it needs to do. Once the create all method is invoked, that is when the tables are actually created and the mapping between the classes and the tables made. So if you want to look at more the examples in greater detail, you can. So also another thing to note is that once you've defined, so now you've defined your classes and you've created your tables, and there is a mapper that exists between the classes and the tables. Now what you want to do is create instances of those classes. So user object equals models.user. For example, we are creating an instance of the user class, and then we want to populate these tables with these values by using db.session.add. So a session is basically like is another class that is used that takes care of all the persistent operations with the database, all the queries, all the flushing into the database, connecting with the DB API and things like that. So you do need to use the commit method, which will be an indication to session to actually do everything in a single transaction, as well as there is something called as lazy initialization, in which the session contains all the information, but it only starts the execution of any of these commands or making any of these queries into the database or any of the insert statements only when it gets its first execution command. So in this case, I think add and commit together are the methods required that will push session into actually making the change into the database. If you want to inspect the queries that are being generated by SQLAlchemy, you can actually enable debug queries in Flask. If you do flask.extension SQLAlchemy, if you import get debug queries, you can use that method to be able to see the queries being generated or to be able to log them. There is a special function called after request in Flask, which can be used. Flask basically gives this provision where you can do certain, if you want to do some kind of processing after every request has been has processed, every HTTP request has been processed, you can use this method. So here I define after request, and in the after request method I say that, you know, for every query that you get, I want to log it. So anytime there is a query that is made to the database, I'm going to log it. And you can use this, or you can just use get debug queries. You can just call this function inside your code, inside your view functions, wherever you want to actually see the generation of queries. Excuse me. So for example, if we can take a simple example where we want to select star from user by username equals Amy. So for this, in the view function, you would have code where you are getting the username from somewhere, either from the request form, or you're getting it, or you're just typing it, hard coding it or something, just, you know, for this simple application. And then to actually run the select statement, the actual format that is used in SQLAlchemy is the name of the class that you've defined, followed by query, and followed by filter by. Filter by is basically similar to select star, and sorry, filter by is actually the where clause. So you want to say username equals Amy here, or you want to say, you know, filter by something else. That's the same as the where clause in your SQL statement. Select is the same as query, and then you can just like you're saying select star from user. In this case, you're saying models.user.query.filter, so you're defining, you're using the name of the table. So basically, that is how all the queries are made in SQLAlchemy. You just start with the name of the class that you've defined, and it has a query class inside it, and then it invokes the method filter by. And also inside filter by, there is a choice that you have. If you only want to get the first result, or if you want to get all the results, you have a choice between calling the methods first versus all. And then you can see that the SQL query was the actual SQL query that was generated by SQLAlchemy. And then this is the result that is obtained, and it is populated in the query object attribute or variable. And so in our database, this was the information. We had populated it with the user ID Amy, the email amy@gmail.com, and the address 20th Street, Manhattan, New York. So that is how you can have a look at the result of any query. I was actually using the PDB, the Python debugger PDB, and to get this information. If you want to use a join between two tables, this is an example of a join where you say if there is a join between user and podcast, you can say user.query.join models.podcast. Models is the name of the file or the module where user and podcast is defined, and then you go on to filter it again using the where clause and then calling the all method in the end, and this is a SQL query that is generated. You can access data if you've got information, if you got the result of a query in, for example, user object. Since user object has a one-to-many relationship with podcasts, you can get information about the podcast for that user that was queried from the database using user object dot podcasts. You can do an update. Instead of using all, you can use update. If you use update, then it is the same as an update statement in SQL. And if you use delete, it's the same as using a delete statement in SQL. You can set debug equal to true and catch SQLAlchemy exceptions and do whatever you want to do with them. These are the important links that you can look at if you want to understand SQLAlchemy and if you want to understand how to use it with Flask. Also, the link to the official documentation of Flask is here. And thank you so much. This was just an attempt to help people who have never used SQLAlchemy before or an ORM before to use with a small web application framework for a simple web app like the one I've used here. And this is specifically for Flask, but SQLAlchemy can be used easily for other frameworks, and you kind of define them in a very similar way. I hope this was helpful. Thank you.